Okay, welcome everybody. Here we go. We're looking at the statistics class, or the 15-week class or 14-week, whatever it is, the shortened version of the statistics course, right? So we are moving ahead. So as you can see, or as you know already, your chapter 1 stuff is due tomorrow. So a lot of people have progressed through that. So remember, the way this works with homework is you can keep working on your homework, the lessons and the assessments after the due date, but you only get half credit. It only awards you half credit for the work that you do after the due date. So it's a pretty big penalty for doing it late, but then you're not left with like 0, where you can't get any more credit after that point. So I highly encourage you to try to get as much of that homework done as you can before the due date, because then you're effectively getting double points compared to what you'll be getting after the due date, right? It still helps your grade, but it's not going to help it as much, right? But I wouldn't recommend just not doing whole assignments. That can start to hurt your grade. I mean, over the course of a semester, if you have one assignment you kind of didn't finish, no big deal. But if it becomes a regular thing where, you're not doing a third of the assignments, that's a pretty tough blow to your grade. Can be difficult. So especially since the homework work is kind of the guaranteed points, right? When you turn in your project, you don't know what you're going to get. Some people are going to get A's. Some people are going to get C's on their projects. Some people will get below a passing grade on their projects, right? Just depends. So the homework really just comes from, are you willing to put the effort in and come get help when you need the help, right? I've had students coming to me and asking me and saying, I'm totally stumped on this question in the homework. Can you help me with it? And then we sit down, and sometimes it takes me a couple minutes because I have to orient myself. And I'm still kind of new with this book series. I've been using another book series for years now, the Triola book series. So the questions are framed a little bit differently. So sometimes I have to remind myself, oh, that's right. That's how you do the problem this way. That's how they want it done in this book. But I'm able to help students through it, and they figure out how to do it, and then they're able to go through and finish their homework. That's what you want. So hopefully by tomorrow you can get that done. But remember, you can keep working on it late. You just get partial credit, okay? Which is not really a situation you want to get into. But if you need it, it's there, right? People are getting sick. People have occurrences come up. Things happen, right? Life's a kind of a weird thing right now. So you just remember, that's an option for you, is to keep doing the homework afterwards. I haven't really had too many questions on this chapter 1, so I kind of assume that means people are getting it. It's really just the stuff in the beginning here. You're not actually calculating much, so people seem to do pretty well with this chapter 1 material. Now, don't feel bad if you're struggling with some of it. Come see me, right? Come get some help, either with me or the tutor center. And they can and we can get you the help that you need in order to do those problems. Okay, so please reach out. That's definitely one of the biggest challenges we're having during this remote learning because of COVID, is people not what I'm trying to think of a good word to use. People not able to reach out for whatever reason and get the help that would be much easier to get if we were in the classroom. I'm one of those people, right? When I went to school, wasn't interested in talking to the teacher very much, or raising my hand and asking questions and stuff. It just wasn't my style, right? So, I realize there's a whole range. There's some students that love to raise their hand and ask questions, which is actually great from a teaching perspective. Some people, even though they're lost, they're like, I'd rather just go home and struggle with this than ask for help. But it really, and I'm saying I was one of those students who didn't really ask for help a lot. But things that can be very beneficial for you is find some people that can help you. A study group, which is one reason I form these groups for your projects. You can talk about other things in those groups when you get together to talk about your project. No one's going to get mad if you say, also on 2.3, problem number 4, did anyone else think that problem was weird? I'm a little confused. And probably someone in that group is going to be able to help you. Right? You can come to me and I can help you through it. And here's the thing about tutoring. The tutoring center has people who can help you with statistics. And they're still doing online Zoom tutoring. So you don't have to go there in person. You can, but then you have the issue of going to campus. And If you're in an online class, most people don't want to go to campus, although I have had occasionally people showing up to my on-ground office hours. They're still doing that, but you have to jump through some hoops. You have to get checked in on campus to get your wristband that you're cleared, and then in a few days here, a couple more weeks, you can't even go on campus unless you're vaccinated. So there's that whole thing, but you still can. So you're welcome to go. Actually, last I heard, I think they are doing on-ground tutoring now, but I believe they're still doing the Zoom tutoring as well. There's a little bit of a struggle going on with the tutoring center and statistics, and that is that we are teaching a whole lot more statistics courses at this school now than we were a few years ago. The school changed a rule about how community college, that it was actually a law. The state passed a law changing the way community colleges organize their math classes, the way you're supposed to progress through them. And one of the outcomes is there's a lot more sections of statistics now, like a lot. It went from being, a reasonable amount of statistics classes that now it's the class we offer the most. We offer more statistics classes than any other class that we offer. So there's a lot of it. But they really struggle in the tutoring center to get statistics tutors. And the reason for that is many of the tutors that tutor math in there are STEM people, engineering, mathematicians, chemists, physicists, all that kind of stuff, where it's the people that are going through the calculus regimen, linear algebra, differential equations, so all that. They know math. They're so good at math because they're literally taking 1 or 2 math classes a semester, and they have to do well. Those people just naturally go, well, it makes sense. I could go make money in the tutoring center helping people with their math. Plus, those tutors are getting practice as they're working in the tutoring center. The problem with statistics is most of our statistics students are not like taking a ton of math. So it usually does not occur to them, oh, I could go work in the tutoring center and I could help people with their classes. The tutoring center is trying to find people who can tutor statistics well. Okay, so if you are someone who like aces this class, check in with the tutoring center and say, I haven't taken calculus in these other classes, but I'm pretty strong with statistics. Do you have some hours for me? But the reason I bring that, and they're always looking for people who can do statistics in there. Because the thing is, most of the people that go the engineering route don't take statistics. And so when someone comes to them and says, oh, can you show me how to make a confidence interval? They're like, I don't know. I never took this class. So it's a little hard. But they are working hard to hire people who know statistics. So what I'll hear from students sometimes is someone comes in and says, I went to the tutoring center, but it wasn't any good. No one in there could do statistics. They definitely have statistics tutors in there. So what you might ask the tutoring center is, are there specific times and days that you have people scheduled for statistics? Because the answer is yes, they do. It's a little weird right now with COVID, but we were actually working on this before COVID even hit, and then it's gotten more challenging during COVID. But there will be times where they say, oh, if you show up at this time and this day, there are one of our stats tutors will be in here. Right, so there is ways for you to get help through the tutoring center. It just takes a little bit more legwork to organize the whole thing, okay? And I, of course, have office hours. I've had students showing up and not understanding how to use StatCrunch. Some of these homework problems you'll see in the coming chapters, very difficult to do by hand. Some of them are reasonable. You could do it in 5 minutes by hand, but you might make a mistake or something. But then when you do it in StatCrunch, it just like does it for you. So one thing I'm finding with my students, because again, I just started using this system. It was a whole different textbook, whole different homework setup than I was using. So I'm still kind of learning. A few of the details are still popping up in this series where sometimes I go, oh, do they want this or do they want this other thing? And I have to kind of figure it out. So here's what I'm finding. Here's how it's gonna, like, not so much in chapter 1, because a lot of this was they mention an idea to you and you're just kind of repeating it in the answer, the little quiz questions or whatever that they give you. But once you start getting into the actual material, you're going to start using StatCrunch more and more. So StatCrunch, remember, you get free access to StatCrunch when you paid for the homework. So when you paid and actually, hopefully you got it free through the bookstore, but when you got that license to do the homework, you also got access to StatCrunch for as long as this class is going. So what's going to happen is you're going to start seeing problems in here. Let's see if I can pull one up that we can look at. So here's a problem. I should have looked at one ahead of time so I could have it all ready to go. It didn't occur to me to pull that up, but let's see if I can get lucky with one. Okay, here we go. So what you're going to see is you get to a problem like this. Now, some of these data sets are going to be rather large that you're going to start dealing with in the coming chapter. And it's a good idea. I would encourage you, whenever you see a new concept, just try to do one of the problems by hand. Take one with a small sample size. Just see if you can work through the calculation by hand. You'd be surprised how much it helps you kind of just organize everything in your head when you've gone through it. Like when we're on ground in class, I have my class calculate one standard deviation by hand. Because it's one thing to just know, oh, I don't know, I have StatCrunch and I push a button and some magic happens and it gives me a number, right? There's a big leap there of not understanding what's going on. But if you've gone through and you've calculated a standard deviation by hand, you go, oh yeah, I understand what it is, because at this point I'm subtracting the data value from the mean, and then I'm getting that distance there that we then call a residual, right? There's all these other topics that come up that make more sense if you've gone through the calculation of a standard deviation. Now, I would never expect you to do that on a regular basis. That's why I say in my classes I have it done once. We do one standard deviation problem, and when we do it in class, it's like 10 data points or 8 data points. So it's not like I'm expecting you to do it with like 30 of them, but it can be very helpful to see, to actually do those calculations so that it's not magic to you, right? It's not Harry Potter waving a wand and then all of a sudden there's a standard deviation sitting there for you on the screen. It's that you actually understand what's going on behind the scenes. And to do math, you should always do math that you understand, right? Now, that said, most of the time, doing these things by hand is super tedious, because even if you have something with 30 data points, that's a lot of calculations you're going to be doing. So it's really nice to have the StatCrunch come in and do that work for us once we understand what that work is. So see, you've got this. So here's the problem. The data in the accompanying table represent the land area and highest elevation for each of 7 states of a country. Complete parts A and B. Click the icon to view the data table. So you go, well, I don't see any data. Where's the data? Right, that's the click the icon to view the data table. So this icon right here, when you click that, look, my data shows up on my screen, and all of a sudden I have the data and I can look at it. Okay, for each state, here's my land area, here's my elevation. So see how we have that data? So this isn't a ton of data. What do they want us to do here? Would it make sense to draw a pie chart for land area? Okay, so they're asking us about like visuals. Which visuals are good, which visuals are bad? Usually the answer to, would it make sense to draw a pie chart for? Usually the answer is no. In fact, the book I used to use, Triola, it just said don't ever use pie charts. But you could, it's anything in statistics, you can make an argument that it's reasonable to make, okay, in this case, you can make a pie chart. There's always like, to almost every rule in statistics, there's a time when you're going to break that rule. It's not true for everyone, but a lot of them. So notice how I got my data. So just to kind of remind you, because you're going to be doing this a lot. So in these upcoming problems, you're going to click this. Now you've got your data. Okay, you can print it if you want, right? See, there's a print button. Probably aren't going to, why would you do that? I mean, you could, but there's really not a ton of reason to do that. But if some of you do, I'm not, look, if whatever works for you, do that. So if some of you like to print it out and it works for you, great. Just keep doing that. Don't let me convince you shouldn't do it that way. And then, of course, you can click done to get rid of it. But we bring up the data. Now, here's what sometimes people don't realize, and I think it's because I kind of don't like this symbol they use here. Like on Windows, this means minimize. So a lot of people look at this and oh, whoops. Actually, sorry, for that one, it does mean minimize. Sometimes this will give you options if you click it. on my every once in a while. But this is the thing you want to be looking for right here. See this little blue square? It kind of looks like a little page. I think it's supposed to be a tiny StatCrunch page or something. I'm not really sure why they picked this icon. Maybe they just had it around, so they decided to use it. But if you click this, it gives you some options. You could open it in Excel if you want, but why would you, right? You can copy the stuff to the clipboard if you want and put it in whatever program you want. If you're like a expert with Excel or you're an expert with, say, Google Sheets or something, fine. Copy it to the clipboard. Open it in Excel if you want. I highly recommend you just use StatCrunch because that's what you're going to be seeing. And sometimes Excel does weird stuff with statistics where it the way they set something up will kind of contradict what you're told to do in your statistics book. So you just really go to StatCrunch. So you click Open in StatCrunch. Now it opened in a totally different window. So let me bring it over here. And see, now I have my data right in StatCrunch. It's all ready to go, which means as you learn to use StatCrunch more, you'll just come up here and go, oh, I know what to do. Let's take my summary stats for column for land area and compute it. And then look what I've got. Like, we haven't discussed all these things yet, but we will be in chapter 3. Your mean, your standard deviation, your median, your range, your min, your max, your quartiles. You're getting all this information, boom, that quick, right? That easy. So sometimes that's what they want you to do in the question is they'll say, what's the mean of this data? They want you to come into StatCrunch and calculate it. Sometimes, like this one's short enough, you could do it by hand. Again, whenever you learn one of these calculations, just once try it by hand, right? And then you go, oh, I understand. And then by all means, after that, use StatCrunch to get it done, okay? You can come in. There's all sorts of stuff in here. There's all these calculators, summary stats, tables, frequency tables. You've got your, in graphs, you've got histograms that we're going to be looking at, dot plots, box plots, stem and leaf plots, pie charts, bar plots, all sorts of stuff, right? A bar plot is usually called a bar graph, similar to a histogram, but a little bit different. Okay, so that's helpful. I see some students not quite sure how to do that. And then once you've done the problem, you just close it. And then there you are. You close this, put your answer in there. I haven't really looked at this, but let's take a look. It's incorrect. You answered no. So, okay. So anyways, I'm just trying to move through the problem quickly. I didn't even really take the time to analyze it, but does it make sense to draw a pie chart for a land area? In this case, they're saying yes, that it does. Some books are very anti-pie chart. This one is a little more like pie charts are a good choice. But it just depends, right? That's the choices you're going to have to make when you're doing your project is, are pie charts a good thing to use or not? Do you want to use a histogram? Do you want to use a frequency table? What are all the things you want to use? These are the decisions you get to make in your project, and that's why it can be helpful after when you get together in your groups and you talk about this kind of stuff. Okay, so we've got that. So moving in, what is it? It's kind of making me stuck here on this part. Okay, let's just close that part. Then let's close that. Oh, right, because I opened it from this window. That's why. Okay, so just make sure you're going through and doing those things, and you should be good. Right? If you're still stuck on chapter 1, if there's some in chapter 1 you're stuck about, you can still see me before the 30th, before it's due, and I can help you through with that stuff. Okay? So you've got your group projects. I'll go through and award grades for that pretty soon. You've got your survey questions, and I know we just talked about it a couple days ago, and people want to do a good job on those, but do be aware you've got there's a little bit of time left, but do try to make sure you get your stuff in here, your questions in here, before this is due, this October 5th, so that we can move forward with the work, right? Your semester's already shortened because this was a late start class. So you're already a little short on time. You already have less time to work on the project than my other class, my Tuesday, Thursday class does. We don't want to shorten it even more by procrastinating with this part of the process that we want to move forward on, okay? All right, so then moving into chapter 2, we have basically a discussion about the types of data, quantitative, qualitative, and the displays that we use for those things. So you'll notice the part of your project that actually kind of pertains to chapter 2, you don't do it for a while. You don't do it until the end of chapter 3. So why is that? Why would you learn something in chapter 2 and I don't have you actually do that work on your project till the end of chapter 3? Well, the reason is because you don't have your data yet. You haven't done your survey questions and you haven't taken the survey. So you don't have your data, so you can't work on your project yet. So you start to see why I bring this up about we really want people to post those questions by the 5th. Make sure you get everything in there. And then we get the survey taken in a timely manner, because otherwise these are going to start getting pushed. Oh, it says the 30th, but don't worry about that. I'll fix that. But these start getting pushed later and later into the semester, and then you're not having the benefit of doing your project work over a long period of time. It's getting compressed shorter and shorter. So that's why it's important. You get your survey questions in there. Just a reminder, each person in the group should leave a post. That's how you get credit. I grade your posts that you put in the discussion board. If you don't get credit. You can't say, oh yeah, Sarah's included in my post. It doesn't work that way. So if you want to divvy up the questions, say your group has 6 questions, 3 people, each person posts 2 questions, great. That's totally fine. However you want to do that. But if you don't post in here, you do not get points. Okay? So make sure you do that. Yeah, because I'm sure I'll get at least one email that says, oh no, my friend said I'm in her group or his group or whatever. Nope, remember that first sentence right here. Make sure you read that. Each group member must leave a posting in order to get credit, right? Oops, I don't want to show grades. Don't show grades. I accidentally clicked the wrong link. Let me get that back. I meant to click modules and I clicked grades. It didn't show anything anyways, but definitely don't want to expose grades. So where are we? Okay, so getting into chapter 2. So remember, the work you do, like when the discussions that I give in class are a little bit more like overreaching and sometimes the subtleties of what's going on. So there'll be things like, you might go, well, he never explained this thing exactly. That's because I know it's in the video and they're going to cover it in this lesson part of the video. So like I'm not going to have to explain to you what the mean is because I know it gets covered in these lessons. But I can talk to you about the subtleties of when to use the mean and when to use the median, right? That's more of a chapter 3 topic. But just remember, we don't have a ton of in-class time, right? We're looking at less than half of what we would have if 40% or something of the meeting time that we would have if we were on ground. So I don't always cover that same information. I'm trying to give you the stuff, the subtleties of statistics that people miss, and it makes them just kind of miss the whole point of what we're doing here. A regular thing that I see is that it takes people a while to figure out the difference between qualitative data and quantitative data. Qualitative data can also be called categorical data. So if you've sometimes when you're in a discussion about statistics, someone to talk about categorical data, that really means qualitative data. It's really important that you know the type of data that you are talking about. And we talked about this a little bit last time when I was talking to you about your survey questions, but I see people getting confused about how to ask their particular questions or how to analyze their questions because they haven't really thought in their head, oh, I'm dealing with quantitative data. Like that should always be the first question out of the gate is what kind of data am I dealing with? Because certain tools apply to certain types of data, right? There are certain tools that apply to quantitative data, certain rules that apply to qualitative data. So for instance, if we took everyone's age in the class, that's quantitative. It's a quantity. Quantitative quantity means you've counted something, right? So we ask everyone in the class their age. Everyone basically counts, what are you really counting when you count age? It's how many times the earth has gone around the sun since the instant you were born. That's years. We count years. Everyone says how old they are. And we could do things like take the mean, right? We haven't defined the mean yet, but think of it as the average, which is a, kind of a bad word in statistics. We don't like to use the word average because it leads to ambiguity. But we could take the mean, you can just think average for now, the mean of everyone's age, and that would make sense, right? We could say, oh, that seems like a calculation that, you could, depending on what you were working on, the mean age of students taking statistics at the school could be helpful, right? When we're trying to make decisions about our classes and how our classes run, there's lots of things we take into consideration. The age of students taking this class. Do the students have other degrees? Have they already earned other degrees? Is this their first degree? Socioeconomic stuff comes into play, all sorts of stuff when we make decisions. So the mean age of people in the class could be a useful thing to look at. What if we looked at the eye color? And this not for decisions about the class, but just, there could be a question on the survey, what's your eye color? And then you're given some choices, brown, blue, green. And then you say, well, I'm trying to take the mean of this data. We can't take the mean of that data. That doesn't make any sense, right? The mean is a numerical calculation, and you're trying to put eye colors into it. That doesn't make any sense. Now, that's kind of an extreme case. I've never actually had a student try to take the mean of eye colors, but I have had students try to take the mean of qualitative or categorical data, and that's their problem, is I'm saying, oh, you're taking numerical data and you're trying to apply non-numerical methods to it. Doesn't work, right? So I gave you like the obvious case just so that you would understand the point that I was making, but it's a popular thing, right? Not that people like doing it, but it's a thing that I see very common. Common is a better word than popular. It's entirely likely that you working in your group, you're going to be working on something and it's just going to seem weird. Something's not right about what we're doing. And then someone's going to go, oh, that's because our data is qualitative and we're treating it like it's quantitative. And then the light bulb goes off. Another reason why it's good to be in your groups, because when you're stuck, you're more likely to have someone in the group have that little light bulb go off and get it and go, oh, I know what we're doing wrong. And then everyone in the group gets helped because that person figured it out. So anytime you're doing data, ask yourself, am I dealing with qualitative or quantitative? Remember, qualitative, it's sort of an older definition of the word quality. When we talk about the quality of something, we're just talking about the characteristic of it. A lot of times when you ask someone about the quality now, they think like, how well is it made? Is it a cheap TV or is it like a really nice TV? What's the quality of it? But the broader sense of the definition of quality just means a characteristic of the thing. Your eye color is a quality of you. It doesn't mean that you're good or bad, or that you're better if you have, one color eyes over the other. Like, we're not in statistics, we're not putting, when we use the word quality, we're not putting a judgment on it as to who's better or not. The quality just means, it could be the quality of your shirt, could be the color of your shirt. That's all we mean. So for quality, think about, eye color. Quantity can be any kind of number that is actually counting. I gave examples before. You can have numbers that are jerseys on a team. Those are not quantitative because you're not counting anything. Phone numbers, social security numbers, those are numbers, but they're not counting anything. So those are not quantitative data. And just always ask yourself, does it make sense to take the mean of this? Does it make sense to take the mean of social security numbers? No, nothing's going to come from that. But we have different displays. As you'll be seeing, the way we organize our data is different for qualitative versus quantitative. So the type of displays that you use to visualize this data, it's very, very powerful to be able to visualize data in these settings. You have different tools for quantitative versus qualitative. So if you start off from the beginning and just make a conscious question to ask yourself, what kind of data am I dealing with? You're going to save yourself a lot of time in mistakes that you don't make along the way. Okay, and we'll talk about this a little bit. Oh, and I just noticed this morning when I was looking at things, I have a chapter messed up. My chapter 4 due dates are messed up. It says October 12th. I'm going to change those so that they're due after chapter 3. So I don't know, somehow I'm not sure what happened with those due dates, but I'm going to update these due dates for chapter 4 so that they will follow chapter 3. They might be about the same time, because that should be plenty of time for you to kind of work on it. But just be aware. I don't want people trying to do this right now before we do this, because it won't make as much sense. So that's actually what I'm going to, let me make a note to myself. To change those. So don't start trying to do chapter 4 yet. Start focusing on, do your chapter 2 and then go through chapter 3, and then by the time you get down to chapter 4, the due dates will not be October 12th. Okay, I'll go through and fix those for you. Right, where was I? Oh, so your displays of data. So once you have your data for your project, you can start going in StatCrunch and start making good visuals for them. One mistake that I saw, and this was kind of new, I didn't see as many. Sometimes you never know. And it could be that we're using this different book, or there's something in the video that makes students do this. But what I saw this time was students taking quantitative data and trying to group it like it was qualitative, right? So for instance, like the age question. The best way to ask the age question is just, how old are you in years, right? And then people are going to put 18, 23, 31, 47, whatever the numbers are, they'll put that in there. Some students were trying to ask the question, and this is reasonable because you could want this, but they were putting it in, say, decade format. Are you in the group that's, say, 14 to 19? Or 20 to 29, or 30 to 39, or 40 to 49. Now, why wouldn't you want to ask the question that way? Because you might say, no, I have a specific plan to use the data that way, and that's how I want the data, that's how I want to analyze it. There's still a problem with that, and the problem is that if you just ask people's age, you can group them into those categories of teens, 20s, 30s, 40s, 50s, and so on. But if you collect the data in those groups of teens, 20s, 30s, 40s, you can't go back and get their exact ages, which makes the analysis a little bit harder and a little bit more inexact. Okay, so what you want to, when you're asking these questions, you want to think about what's the best way, the best way to ask the question may not exactly be the way you're going to analyze the question. So in other words, what you would do is you would take the data for age, and then if you wanted it by decade, then you can organize it that way in a frequency table, right? You can create a frequency table for it. StatCrunch will do frequency tables, although I find it a little bit difficult with the frequency tables because they don't let you control your bin, but you could do it by hand easily for like generations. You would just go through and count each one, and you can create your own frequency table by hand. Group by yeah, you can do it, but it takes a few more steps to group by frequency table here in StatCrunch, but it's doable. So just think about that. Think what is the most powerful way for us to collect our data so we have the detailed data, and then if we want to group things later, we can do that. Okay, that is a mistake I saw. Like 3 or 4 different groups tried to do that same thing, not with age necessarily, but with different groupings, where they were, instead of just asking the question, they were giving groups. For quantitative data, you might as well start off with the actual values, and then you can do whatever you want with it later. Okay. Okay. One thing that's coming up, so one of the big visuals that you're going to be using in statistics is what's called a histogram. It's very popular. The histogram gets used a lot. You should definitely have histograms in your project, right? I mean, I guess it's possible there's a scenario where someone can say, oh yeah, I didn't think a histogram was the right way to do it, but you should have a very, very good reason why histograms weren't there, because out of 5 to 8 questions, I find it hard to believe that you wouldn't have at least one thing that would make a good histogram in there. So it's big. You're going to learn a bunch of visualizations. You got your pie charts, you got your dot plots, you got box plots, you got histograms, frequency tables, all these kinds of things. But histogram's kind of a no-brainer. You should probably have some histograms. One of the nice thing about the histogram is it instantly shows us our data, right? It shows us the shape of our data, which we're going to get more into chapter 3. There's two really big concepts that are like questions 2 and 3 when you have some data. So remember, I said the first question that you should ask when you have some data is, what type of data am I dealing with? Am I dealing with quantitative data or am I dealing with qualitative data? Your second question should be, how should we figure out the center of our data, which we'll talk about in chapter 3? And then your other question is, how should I figure out the shape of my data? Right? What's the appropriate way to get a sense of the shape of my data that I'm looking at? Those are like your first 3 questions, because those questions are going to spawn more questions that allow you to sort of fill in more work. But they also answer a lot of questions for you along the way. So let's pull this up. This is from a different book. It's the Triola book, but I just found an old PDF version of it online. Just literally, I'm not suggesting that you do this, but I'm not suggesting that you don't either. It can just be handy to have something with definitions, although it's a different book, so they do things slightly differently. Things in Triola are done a little bit differently than in the book series that we're using, but overall it's the same basic idea. So the big one that we're going to use that you're going to be looking at is histograms. Where'd the histogram go? Oops, there's some histograms right here. Here's some examples of histogram. Whoops, here's some examples of histograms that we're looking at. And some of you might go, isn't that a bar chart? No, histogram's slightly different. But there's an intermediate step that you usually have to go through before you make your histogram, and that's called a frequency table. So let's take a look at that, and I can kind of make sense of these two things for you. So before we get into the histogram, let's look at a frequency table. They talk about frequency distributions. So this is what I was talking about a moment ago. And we're here. Where's the definition I want? Here we go. There's definitions with a bunch of parts of a frequency table. But the thing is, like, you would think it's really complicated by reading all this. It's not too bad. It's just there's little details in there you have to sort of keep track of. But your frequency table is basically like this thing here. You're taking ranges of things and you're figuring out how many fall in there. So this is a perfect example of what I was talking about a minute ago. You would just ask people in the class, what are your ages? Okay. Now, if you wanted them and you said, no, but the way I want to analyze my data is by decades, fine. You would have, instead of IQ score right here, you'd have ages, and then you'd go, whatever. You'd go 10 to 19 would be your range here, and then you'd count how many people fall in there. And then you'd go 20 to 29. You'd count how many people fall in there. 30 to 39, you'd count how many people fall in there. And that's what the frequency table tells you. Because if you just have this big string of numbers, your brain gives up and you're not able to analyze it by looking at it. But if you break it down into, say, decades, then you go, okay, here's how many teens, here's how many 20s, here's how many 30-year-olds we have in the class in their 30s, and then you can keep track of them a little bit easier. Right. Now, there's little details, but those little details are like, that's what they are, is they're little details. They aren't big things that make a big difference in how the problem is done. It's just little tables. So your lower class limits, the lower class limits are the beginnings of these ranges. Your upper class limits are the ending of your ranges. Okay. Now, there's a few ways you can do this, and you can calculate the class width. That just means how wide is your range. You could count ages by every 5 years. You can count them by every 10 years, or group them by every 5 years, group them by every 10 years, group them by 20 years. However you want to do that, you can choose that grouping. So there's your class width. So pay attention to those details when you're working with these frequency tables, but just realize that, like, overall the idea of a frequency table is pretty straightforward. You've got ranges over here, and then you just count how many of your data values fell inside those ranges. Okay, So it's not too bad. So you'll make some of those. Most of the time, students are pretty comfortable with those. Frequency tables are not too bad. Okay, it gets a little bit fancier than that. We build on top of frequency tables. With frequency tables, we can do a lot of other things, but they're really helpful. Like, look here, these are pennies. Someone randomly selected pennies, and we have the weights of pennies, and then we have the frequency. So this would look even better in a picture, but even this frequency table gives us some information. Imagine we had a big list of numbers that went from 2.4 to 3.19. It was all the data values. Well, if they're just in a big list, you're going to go, I don't know, there's like a bunch of numbers, and most of them start with a 2, and some start with a 3. I don't know. But this frequency table helps really, there's something kind of interesting that should catch your attention when you look at this. And it's that, why do we have a bunch of pennies that are down here in the 2.4 to 2.6 range? So you might say, well, why are they different weights anyways? Well, there's lots of reasons. One, when you manufacture things, they don't all end up being exactly perfect. This is one of the ideas of quality control in a manufacturing plant, is you want to be able to track how, are we producing the same thing every single time, or is there a little bit of variance? And almost always there's going to be some variance, right? The alloy that you're using, on one coin might be just a slightly different mix than the nickel that was, or the penny that was made after it. So you're going to get a little bit of variation. Also, when pennies are out in the world, things happen to them. They get damaged. Parts of the ridge, that sharp ridge on a brand new penny can wear down. Some of that metal wears off. They can get deformed. They can pick up dirt. While they're, sometimes you see a penny with just is almost like gum or something on it. Like there's like a bunch of gunk. That's obviously going to weigh things. So you're getting a little bit of a range. And then we get some zeros and then another grouping here. So that seems kind of weird that there's a grouping here of pennies and then literally nothing. And then a grouping here again. I wonder why that would occur. And that's what you should be doing as a statistician, is you look at your data and go, that's weird. What's going on? Well, what's going on is that in, I forget, some 1983, I think, it looks like it says 1983, they changed the way they produced pennies. Okay, so if you went back and looked, what you would find is all these pennies up here in this range were created before 1983. All these pennies after that are down here were created after 1983 because it became too expensive to make pennies out of copper. So now they're mostly zinc, right? So sometimes looking for weird things in the data can start you down the path of being able to explain things you didn't already know. We didn't know, or some of you may have known, but most people don't really even care, so you probably didn't know, that in 1983 we changed the way we make pennies. Well, by looking at our data, we knew something happened, something's weird, and then you could go back, you could try to find what's different about these pennies up here from these ones, and then you could start to sort of fill in that investigative pursuit. Right now, again, no one's probably cares too much about pennies in this class, but you see the concept, right? You see the idea of, something weird is happening here. Let's try to figure out what it is. That's what statistics does, is you find weird things happening in, or relationships happening in sets of data, and you try to explain why. You try to figure out, why is this occurring, right? So finding gaps can be very helpful. Okay. Coming up, one of our discussions is going to be about the shapes of data, and one of the best ways to see the shapes of data is with a histogram. A histogram is a graph consisting of bars of equal width drawn adjacent to each other. The horizontal scale represents classes of quantitative data values. So it's saying the horizontal scale represents classes of quantitative data. So see how I was talking earlier about you always need to know what kind of data you're dealing with, because then you can use the right tools. They're saying right here, histograms are for quantitative data values. And the vertical scale represents frequencies. So Your horizontal axis is measuring something quantitative, and then your vertical axis is saying how many of those occurred. Well, that's kind of what's in your frequency table, right? So that's why the frequency table is done before the histogram, because once you have your frequency table, you just turn it into a histogram. A histogram is basically a picture version of a frequency table, which is oftentimes easier to read and easier to compare. That visual part of your brain oftentimes is able to pick up things that you won't see just looking at the text in our frequency table form. So here's some examples of two histograms, right? Which you'll get more in depth with when you do your data. But see how we can get lots of different shapes here? This one here is what we call uniform distribution. Right? The outcomes, they're not all exactly the same, but you wouldn't really expect that, right? This is the kind of thing you would expect if you were rolling a dice a single time and you were, I guess in this case it would be, what, a 10-sided dice from 0 to 9? But if you were rolling a 10-sided dice and you rolled it 10,000 times, you wouldn't expect to get exactly the same number of 4s as 7s, right? You would expect there to be a little variation, but you would expect them to be close. If you're doing something like rolling a fair dice, you expect about the same number of 3s as you do of 4s, as 5s and 7s, and whatever kind of dice you're using. This is what you would expect from rolling a dice, is a uniform distribution that looks like this. In StatCrunch, they actually have a few simulations. One is these different dice rolls, which we'll look at different times. They're actually kind of fun to play around with, and they really help give you a sense of when you would expect to see these different types of shapes, right? Over here, this is what we call skewed to the right. So skewed means, like, this is what we call a normal, and by normal, that's capital N. It's not like normal like we use in the everyday language. We're like, oh, it's just normal. It's capital N normal, which means symmetric and bell-shaped, right? Now, this data here is not perfectly symmetric, is it? You're never, in real-world data, you're never going to have perfectly symmetric data. So don't expect that. But you could argue this is roughly symmetric. If I folded this over on the center, this side would roughly line up with this side, right? Yeah, okay, we could make that argument. And it's roughly the shape of a bell, right? You bring a little bell. We call that a normal distribution. Skewed is almost like someone stood on one side of the bell and pushed it in one direction, right? You can imagine if someone was standing over here and pushed against this, you could see it kind of piling up like this. So see how this side is now steeper and this side trails off in a tail? We can't really argue that's symmetric anymore, can we? If I fold this in half and fold it over, this side will not line up even close to this side because this one's got this long tail on it. We call this skewed. Now you might, whenever your data is skewed, you should ask the question, why? Why is my data skewed one direction? If we graphed people's ages at Ventura College, we would see skewed data. We would see, starting around 14, 15, you'll get a few people, 16, 17, couple more. All of a sudden at 18, it's really high. 18, 19, 20, lots of people. And then still a fair amount of 21-year-olds, but then it's going to start leveling off, but it's going to go on a long way. We're going to get this tail because you're going to have people of all sorts of ages. You got, as you increase through the 20s, you're going to get less and less people. Through your 30s, still people in their 30s coming to community college for whatever reason. People, every person has a different story, and they're perfectly valid to be coming to the college. In your 30s, you're going to see some people. Then in your 40s, less people, but you still see them, and it's kind of going to go off. I had a person in my stats class. She was almost 70 taking statistics. Good for her. That's great. But you don't see a lot of it. You don't see a lot of 60-year-olds coming to the college, but you see some of them, right? So in that case, you see how I took the shape of the skewed data for ages. I just sort of imposed that on here. But you can make a narrative out of it. You can convert that math into a story that you say, yeah, I have good reason to believe that this story describes the data. You're constructing that narrative in a way that makes sense, right? Why does it boost up at 18? Because most people don't go to community college before age 18. But, a few people start taking classes in high school. But most of the time, a typical student would be someone who just graduated high school, Next fall, they start at community college. So lots of 18 and 19-year-olds, and then it kind of goes down from there. You want to try to understand why that skewing is occurring. Sometimes you won't expect that skew to occur, and you see it and go, I wonder what's going on here. And then you start analyzing the data, and then you learn something new. That's kind of how it works. That's the whole point. Okay, so I just barely introduced histograms. We'll get into that more next time. Let me see. Where's my? I want to make sure I click the right tab here and don't show something grades or something like that, or emails. Right. So make sure you're working through your chapter 2 stuff. It shouldn't be terribly difficult. Much of this stuff can actually be done inside of StatCrunch, and a lot of it is just learning the different types of graphical representations. A big one again. The best thing you can do for yourself, each time you deal with a type of data, ask yourself, is it quantitative or qualitative? And then that will lead you as to what types of tools would be appropriate for that thing. And we'll talk next time about some graphical misrepresentations of data that are sometimes just done poorly. Sometimes they're actually done to make you think that a set of data says something that it doesn't. We see this all the time in the news and politics and all sorts of stuff where data is getting twisted around, and we misrepresent the data because if I know that you don't know stats very well and I show you the graph of a misrepresentation, but it suits my, what I want you to think, then I'll show that to you, right? I mean, I won't, but lots of people will who have an agenda. Will intentionally show you misrepresentations of data. So we'll look at some good examples of that next time. And then you can continue with your chapter 3. And like I said, I'll change these due dates for chapter 4. I don't know how I ended up not changing those, but I'll fix those right now. You can expect them to be due sometime right after chapter 3. And then these due dates for the survey stuff, I can't really set those until we have the survey released and taken. So I'll update those as soon as people have actually, as soon as you have your data, we'll update those and get those taken care of. Okay. As always, anyone who wants to talk to me in Zoom, welcome to do so. Otherwise, keep up the good work, and I will see you next time. All right. Thanks, everybody.